Now we will try to derive the expression for the Fermi energy at absolute zero Kelvin. We are aware the Fermi energy is the highest occupied level of the electron at absolute zero Kelvin. So what is the expression for it? We are very sure that the Fermi energy should depends on the number of electrons that are present in the material. And to find out, if you try to take an arbitrary energy E and E plus D, the total number of energy state called as the density of states is given by 8 root 2 into pi into m to the power 3 by 2 divided by h cube into e to the power half into d. That is a expression which you already did. This will give you the total number of energy levels per unit energy state. Now in each energy, according to the Pauli's exclusion principle, there are 2 electrons are going to be present. But all the energy levels are not occupied at any given temperature. There are certain energy levels are being occupied, but all these are not going to have 2 electrons. Therefore, the question is that how many number of electrons are present? The number of electrons are present represented by the equation n of E d, with the total number of electrons within the range E and E plus d is given by the product of G of E, D and F of E, because it depends on the probability and that depends on the total number of energy levels that are going to be present. Now, if these are the number of electrons only within this range of energy level, what is the total number of electrons are going to be present? So, the total number of energies present within the energy band is given by the integration of this n of E d from the minimum energy, that is the lowest energy, I call it as a zero energy, to the maximum energy, I write it as a maximum energy. So, the total number of electrons that are present per unit volume depends on the integration of the number of electrons present within this range. But we are aware n of E d is nothing but it is going to be G of E d into F of E. So integration from 0 to E maximum. But if you consider at absolute 0 Kelvin, the Fermi energy, the probability is equal to 1, not the Fermi energy, it is the probability is equal to 1. Therefore, I can say n is only depends on G of E d from 0 to E maximum. But G of E d according to the first expression, I can write it is going to be equal to integration of 8 root 2 into pi into m to the power 3 by 2 divided by h cube into e to the power half into d from 0 to E maximum. So I can try to take all the constants out. 8 root 2 into pi into m to the power 3 by 2 divided by h cube, and I can integrate only e to the power half into d from 0 to E maximum. I am sure that you are aware what is the integration of E maximum, e to the power half, which is nothing but e to the power half plus 1, which is equal to 3 by 2 divided by 3 by 2 from 0 to E maximum, and this 8 root 2 into pi into m to the power 3 by 2 divided by h cube I can write as it is. This is going to give you the number of electrons. Now what is E maximum? We know at absolute 0 Kelvin, the maximum energy of the electron is always equal to the Fermi energy at absolute 0 Kelvin. I will write E of 0. Therefore, the above expression I can write n is equal to 8 into root 2 into pi into m to the power 3 by 2 divided by h cube into this 3 by 2 I will write is going to be 2 by 3 into E f naught to the power 3 by 2. E f naught to the power 3 by 2. Or you rewrite the expression for E f naught. E f naught to the power 3 by 2, which I can write is equal to h cube divided by 8 root 2 pi m to the power 3 by 2. I can write 8 root 2 into m to the power 3 by 2 together as 8m to the power 3 by 2. I can write together into the remaining factors, that is equal to 3n, this 3 and n divided by pi. Now here E f naught to the power 3 by 2. Therefore, what is exactly E f naught? E f naught is nothing but I have to take 2 by 3 of this, where it is going to become h square and here it is only 8m is remaining, and here since there are no powers, so I can write E3n by pi to the power 2 by 3. Now this is the actual expression for the Fermi energy at 0 Kelvin. However, if you see here, h square by 8m into 3 by pi is a constant. So I can try to put it as a b into n to the power 2 by 3, which is called as a EF naught. I can write it as a constant where b is nothing but h square by 8m into 3 by pi to the power 2 by 3, which if you substitute, because all these are constants, it will come across 5.85 into 10 to the power minus 38 joules. And from this expression, it is very clear that the Fermi energy at absolute 0 Kelvin depends only on the number of electrons. It only depends on the number of electrons. Therefore, more and more is the number of electrons, Fermi energy increases. Say in the case of copper, the number of electrons are less. So, Fermi energy also is going to be less. It comes around 7 electron volts. But in the case of aluminum, the number of electrons are many more, around 18 into 10 to the power 28. Naturally, the Fermi energy also going to increase in accordance with this expression. That is how Fermi energy of any given atom can be calculated. If I try to take the Fermi energy at greater than 0 Kelvin, even though I am not deriving that expression, then the equation for the Fermi energy any given temperature is given with the relation. It is the Fermi energy at 0 into 1 minus pi square divided by 12 into kT divided by EF naught the whole square. This is what the expression for the Fermi energy at any given temperature. However, you can very clearly see that this is a very, very small quantity. There is a reason that Fermi energy is almost independent of the temperature. It is almost independent of the temperature. Therefore, I can say Fermi energy is independent of the temperature, where the change what is going to take place here is infinitesimally small. Therefore, this is how the Fermi energy of any given material that can be calculated. Now, let us try to see what is the Fermi velocity. What is the Fermi velocity, which I represent as Vf. There is a Fermi velocity. By definition, Fermi velocity is the velocity of the electrons at the Fermi level. It is a velocity of the electrons at the Fermi level. Therefore, at Fermi energy, the velocity of the electron is equal to half mvf square, where vf is the Fermi velocity. Therefore, I can rewrite for Fermi velocity as it is going to be square root of 2 into ef divided by m. This is the expression for the Fermi velocity of any given electron at the Fermi energy. The next is what is called as a Fermi temperature. Now, the definition of the Fermi temperature says that it is the temperature at which the average thermal energy of the free electron is equal to the Fermi energy. Here you can see the band where this is the Fermi level. All these energy levels are being occupied at absolute 0 Kelvin. All these energy levels are being occupied at absolute 0 Kelvin. At absolute 0 Kelvin, no electrons are going to be present above. But when I increase the temperature, some of the electrons are here. Now, look at 0 Kelvin. What is the average energy? You can go on adding the energy of all these electrons and find out the average. The average may be coming around somewhere around here. This is the average energy. Suppose if I increase the temperature, the electrons will jump here or jump here. So now average energy goes on increases. At what temperature the average energy going to be equal to the Fermi energy? And that temperature is exactly what is called as a Fermi temperature, which is being represented as Tf. And this Tf is always equal to the Fermi energy divided by the Boltzmann constant. Therefore, Tf is always equal to Ef by K, where K is the Boltzmann constant. That is the Fermi temperature. Okay, so these are the few things that will be able to understand. Thank you.